Right now, millions of people are walking through cities that sit deep beneath the ocean, where 7 meters of roaring Atlantic Ocean hangs directly above their heads.
17 million lives living inside an artificial hole carved out of the sea.
And only a single, engineered barrier stops the water from drowning them all.
In the freezing winter of 1953, the North Sea launched a catastrophic assault.
Dikes ruptured across the coast, drowning 1,800 people in a matter of hours.
Desperate to save 3 million residents, a local mayor made an insane decision.
He ordered a captain to ram his cargo ship directly into the collapsing dike.
The ship blocked the water, but the government realized temporary fixes were useless.
They drafted an impossible plan: permanently shorten the entire coastline by 700 kilometers.
Step 1 was the Afsluitdijk, a 32-kilometer wall straight through the open sea.
10,000 workers built from the center of the ocean outward into the waves.
Before dumping clay, they sank giant mats woven from willow branches to the seabed. Without these mats, the ocean currents would wash the foundation sand away instantly.
Then a silent killer struck. Millions of shipworms ate the wooden foundations from the inside.
Engineers replaced the rotting wood with volcanic basalt, the hardest rock on Earth.
Closing the final 50-meter gap became a violent battle against raging tides. They waited for slack water, the single fleeting minute when the tide stops moving.
Dumping thousands of tons of rock into the gap before the current roared back.
In a single afternoon, an entire raging bay was converted into a calm inland lake. 90 meters wide at its base, it has held back the North Sea for nearly a century. With the bay sealed, engineers launched the largest land reclamation in human history.
They built massive steel ring dikes around sections of open water, then started the pumps. Giant industrial turbine pumps ran non-stop for 27 consecutive years.
Draining the lake to reveal an ocean floor unseen for 10,000 years. Wild reeds were dropped from plains to absorb water and bind the loose mud. Turning wet ocean mud into some of the most fertile farmland in the world.
Tractors began plowing crops 5 meters below the level of the ocean.
Engineers mapped out entire cities, roads, and power grids on the empty seabed. But as the soil dried, a new engineering disaster emerged. The land began sinking.
To stop the clay from collapsing, automated gates maintain precise water levels inside the soil. Pumping stations must run 24 hours a day, 365 days a year.
If these pumps ever fail, the entire province begins returning to the sea within days. They created a new province, but the Atlantic Ocean was preparing a deadlier strike. To seal the dangerous southern estuaries, engineers built 5,000-ton concrete caissons, flooding the dry docks to float these concrete leviathans out into open sea. Tugboats fought fierce ocean currents to tow the floating concrete blocks into position. Heavy seabed anchors held the caissons steady
against spinning underwater currents.
Opening flood valves to sink the concrete structures precisely onto underwater stone beds.
Aerial cableways strung across the estuary drop tons of stone into racing tides.
When the estuaries were sealed, saltwater ecosystems collapsed, killing millions of marine species.
Protesters chained themselves to construction equipment, demanding the tides be allowed to flow.
Engineers scrapped their original solid dam designs, extending the project by 10 years. They engineered the Eastern Scheldt, a dynamic barrier that stays open during calm weather. Sliding 62 massive steel gates shut only when severe sea storms approach. To construct it, they first built an artificial island in the middle of the rough sea. Casting 65 concrete piers, each requiring millimeter-accurate guide slots for the gates. Lowering giant concrete mattresses 30 meters underwater to prevent sand erosion. A specialized ship named Austria was built solely to lift 18,000-ton piers. Concrete was poured continuously around the clock as the formwork climbed upward. Piers were lowered into the turbulent sea with a tolerance of just 20 centimeters. When a 15-meter void was discovered beneath a pier, engineers injected high-pressure grout. Hanging 62 480-ton steel gates into the concrete channels. Each gate was equipped with its own hydraulic motor and manual emergency handwheels. On October 4, 1986, the barrier was officially declared operational.
All 62 gates dropped at once, sealing 9 kilometers of coast in 75 minutes.
75 minutes to convert an open estuary into an impenetrable steel fortress.
38 years of salt water constantly corrodes the machinery, requiring relentless maintenance.
Tested 30 times against real Atlantic storms, the barrier has never failed once.
Protecting Europe's largest port required a barrier that wouldn't block trade.
Engineers designed Maeslantkering, 2 gate arms heavier than the Eiffel Tower. Hollow steel structures that float out into the river and fill with water to sink. They excavated 2 massive dry docks on opposite sides of the busy shipping channel. Pouring a continuous concrete platform underwater while cargo ships sailed overhead. Welding 210 meters of high-strength steel frame for each gate arm. Anchored to the shore by 10-meter steel ball joints, the largest ever forged. When storm alarms sound, dry docks flood, floating 6,800 tons of steel. During initial trials, a 340-millimeter tilt alignment error threatened disaster. Engineers adjusted water ballast across 26 internal chambers to level the structure.
The entire complex is governed by an autonomous AI computer named BOS.
BOS monitors sea levels and triggers closures automatically, removing human hesitation.
Swinging 237-meter steel arms across the river in 2 hours. Opening internal valves to sink the gates onto the riverbed, creating a watertight wall. Holding back the full weight of the Atlantic, while Rotterdam stays dry and safe. For smaller river routes, engineers invented inflatable rubber barriers.
3 rubber bladders made of Kevlar inflate with air and water in just 60 minutes. Tested to destruction in laboratories to ensure the fabric never tears during a storm. Lying flat and invisible on the river floor until a 10-meter seawall is needed.
Rising to block storm surges without needing cranes, towers, or permanent gates.
Equipped with secondary air compressors and redundant valves to guarantee deployment.
Engineers discovered water seeping beneath the foundations, forcing advanced grouting techniques.
In 2011, they dumped 21 million cubic meters of sand in a single coastal location.
Instead of dredging every 4 years, natural waves distribute sand along the coast naturally.
Using the ocean's own energy to continuously reinforce the natural coastal dikes.
The Room for the River project introduced a new philosophy: stop fighting the water.
They excavated secondary river channels through farmland to give floodwaters room to expand.
Lowering peak flood levels by 27 centimeters, enough to save entire cities.
Placing artificial sand dunes in front of old sea dikes to absorb wave impact first.
30 individual engineering megaprojects now operate as a single national defense grid.
90 years of civil engineering, each barrier evolving from the lessons of the past. The Dutch now export their hydraulic engineering technology to vulnerable coastal nations globally, creating the most advanced flood defense network ever constructed in human history.
0 flood deaths since 1953, because a nation refused to let the ocean conquer them.
$100 billion fortress built out of steel, concrete, and unyielding will. Proving that when nature threatens to erase a nation from the map,
human ingenuity can build a world beneath the sea that stands forever.
Production note: every frame in this video has been transformed through a multi-stage editing process. From GIF conceptualization to VO3 generation, human creativity leads every step. This channel is dedicated to original AI craftsmanship and follows all 2026 YouTube monetization rules.